In the big bilge tank.
We'll keep you in the know.
In the big bilge tank.
We'll fix your techie woes and we'll break things and we'll make things till we're all together raking and
We'll raise a cup of grog down in the big bilge tank. In the big bilge tank. Come and join our pirate crew. In the big bilge tank.
We will show you what to do.
And we'll hack it till we crack it.
and we'll tell the world about it and forget to tidy up.
That's why it's now a bilge tank.
Hello, welcome to Bilge Tank number 58. This is a very unusually timed one that we're rattling out before heading off to, make a fair Berlin. So, guten Tag, Berlin.
Yeah.
Sandy is going to be doing science. He's got a small lab here. This is basically automation hat, which we've... Well, explain what you've done, Sandy. What is this
Well, we'll talk about automation hat first, and then we'll do the demo. So essentially, what I'm going to do is show the 12-volt relays that are on automation hat, working with a peristaltic pump to pump what are hopefully going to be precise measurements of liquid between various places.
So you know the timing right to get them precise.
Yeah. So I've spent the morning kind of calibrating this, so it should hopefully work.
So the relays are up to 24 volts, but you've got a 12-volt peristaltic pump.
That's right.
Yeah.
Bench power supply, which is going to supply the power.
For your volts.
Although that could be a power brick, couldn't it?
It could be basically anything.
So the basic setup with the relays is you're going to have your own power supply up to 24 volts and something you want to drive with them, and then use the automation hat as the buffer between that world and the 5 or 3.3 volts of the Raspberry Pi. You're going to try and measure the voltage as it's drawing as well to see what it actually is.
Yeah, that's we've not kind of rehearsed that at all, so we're going to have to do that on the fly. But let's talk about automation hat in case people don't know what it is already.
Focus, because it's fixed focus.
So automation hats are all singing, all dancing home automation and monitoring hat. So it has 3 each of 0 to 24 volt inputs for kind of monitoring the state of any kind of device that is either 12 or 24 volt.
Or in fact anything, what was the...
Or 5 volt
minimum
or 3.3
threshold voltage of the inputs again?
So the minimum threshold is basically below 1 volt is off.
Yeah, and then above
3 volts is on.
Yeah.
Okay.
Between 1 and 3 volts is kind of not defined. It could be on or off. Then there are 3 outputs.
Those are the standard tricky outputs that we tend to put on everything, which are via a Darlington array.
So again, they're 24 volt tolerant outputs. So essentially, you connect them preferably, I think, on the high side of your 24 volt or 12 volt device.
That is the relays. For the outputs, you have to connect them between the output of your device and ground because they're Darlington buffers. So they're a transistor pair that basically inverts your logic. So you turn your pin high, transistors turn on, and they connect your circuit down to ground. Which is really confusing for everyone who uses this.
Food, glorious food.
Yes.
Yeah, this is why we don't do Bilge Tank.
That's the meat dinghy. Comes by every day, preferring kind of Greg's level or slightly better than Greg's level pasties and sausage rolls. Yeah.
You're missing out on.
Yeah. We should probably send word that we want lard. We need lard. Heck, we're going to Germany. We're going to get all the worst we want.
The worst. Currywurst, man. Currywurst.
Then there's the ADC. So that's for taking voltage readings. Again, there are 3 24 volt tolerant ADC channels.
There's also one 3 volt tolerant one here somewhere. It's on this little 3 volt breakout header because it's 4-channel ADC, so why waste it?
It destroyed the symmetry, so we made 3 24 volts and then kind of tucked away the other ADC on that little header. But yeah, there's 4 there really.
Yep.
Everything mad.
And then I guess the main thing is the 3 relays. So they have both a normally open and normally closed side. So you can connect your device across whichever side is most convenient for you. Everything also has LEDs to show you the state of each of the inputs and outputs and ADC channels and relays as well.
We're basically incapable of making a board about anything.
It's like a very industrial disco, isn't it? Which is, it's going to go down well in Berlin.
Interesting, the LEDs are driven by the same chip as... I forgot that, Pyglow.
The SN32.
The SN3218, yes.
Yeah.
Which means that you can take complete control over all of these LEDs and their brightness, should you wish, and have them not correspond to anything at all.
Turn them into marching ants around the edge of the board.
Whatever you want to do.
Cool. On the back of the board as well, we've labelled which GPIOs, which BCM GPIOs they're connected to.
Quite possible that viewers with large televisions may be able to make some of that out, but I can't read a word of it.
We'll get a close up later.
Yeah, let's go to
we don't want to destroy your surprise though. Oh, there we go.
So everything's labelled up on the back.
And on the front, it's like two different labelling schemes. So there you can do your research, and then when you put it on your Pi or your Black Hat Hacker or whatever, you've got the information on the front, which tells you where the inputs are, if they're syncing or sourcing, and all that kind of jazz, really. Yeah.
Yep.
Useful.
So that's the front as well. So there's also these 3 LEDs up here. They're coloured LEDs.
They're completely user controllable as well. So
yeah.
Power doesn't necessarily have to mean power.
So they are green, blue, and red.
Yeah.
Yeah, and they're basically just for they're controllable in the software. So you can basically make them do whatever you want. We've labelled them up with labels that we think are useful, I guess.
But sticking a sticker over those,
yeah,
there's enough room there to put a little sticker in with your own thing, saying like beer, home time,
beer.
I don't know, something like that.
So
cool.
So in the software, Phil, you've set the LEDs to be linked to.
Yeah, there's a little loop that spins up basically and constantly checks your inputs and your outputs and sets the LEDs to match whatever's going on with the board. So the ADC, for example, it will set the brightness of the LED to correspond with the value of the ADC reading, which is kind of nice if you've got a nice broad range.
It's pretty cool.
And then same for the inputs. If it detects an input signal, it will light up the LED, even though that's happening in software, so it's not a hardware thing. So but it does. It has the desired effect. It looks cool, and it lets you know stuff is happening.
Yeah. We've got a question. If you turn the relay on and then switch the power off to the Pi, will the relay stay on?
That's an interesting question. I believe the relays are like a little spring-loaded contact with basically an electromagnet that sits something like that. So normally they're sitting on their normally open side, which means the relay is connected from common, which is my elbow, across to the normally open terminal, which is over here. And then your electromagnet over here, when you turn it on, it goes ka-doop, and the relay switches over and connects to the normally closed terminal. So when you turn your Pi off, because it's a sprung-loaded metal reed or whatever it is inside the relay, it's just going to go back to the normally closed, or normally closed side.
Normally closed, yeah. Cool.
Yep.
So clues in the name, isn't it?
It doesn't stay on, it switches to its other state. There's 2 states of the relays.
We can try that out, actually. Closed. We can totally...
yank the power. Actually, no, we've got an individual power supply for the actual motor, so we yank the Pi power.
Mm.
They are, in fact, non-latching, I believe.
We're going to try that. We'll find out right now, live on air.
Yeah. So I am currently... well, do you guys want to talk about the USB cables while I just quickly set this up?
Well, something's making me order these by ascending order. So what's the story behind these USB cables, Paul? Once for how have they come?
We've kind of bumped into lots of USB cables over the year, and they've been just some of them have been a little bit crappy. We found
say that again.
before we knew anything, we kind of got random cables from all over the place, and some of them just didn't stack up. This is the reason that the Raspberry Pi Foundation made their official power supply. It's because they found that USB cables were a bit patchy, and it just it made things drop out. It made things not work properly because there was this drop across the power supply line, across that cable, because it just wasn't thick enough to take the current.
It's ridiculous, isn't it? Absolutely.
Yeah.
But I suppose up until recently, USB cables were only really made to handle fairly low amounts of current. I mean, the USB spec itself is up to 500 milliamps, so then you come along and you start powering phones and charging phones from it, you start powering Raspberry Pis, and you're demanding 2 point whatever amps through your USB cable. Stuff is going to get a bit scary, which is why these are so incredibly thick.
Yeah.
They basically have the gauge wire required to carry the sort of current that things like Moat and Flotilla and stuff demand from the system. Super duper useful.
Yeah, so
we're going to do another Bilge tank where we actually hook these up and test them properly and see what the voltage drop is across the cable at different voltages exceeding 5 volts, because hey, that's fun. And with a programmable load, so we can configure the load as well. So we'll be able to show reasonably accurately how these cables will perform under certain circumstances, under certain conditions. It looks like I'm holding a very angry spider.
So depending on the cable, you'll often find that the power lines in them are something like 28 or 30 org by the American wire gauge, which is a bit tiny when you're talking 2 amps. And of course, kind of by the Faraday equations, Ohm's law, the kind of the resistance of the cable will be current dependent, nothing to do with the voltage. So that's really important to have thick cables, so you don't get loads of resistance burning off, all that power that you want to use on your Pi. So these, I think we got 22 org in these, based on what we did for Moat and Flotilla. And we just thought having some known good cables would be
yes, the best debugging solution ever. Are you using one of our decent cables?
And the teeny ones as well.
So we had these in red already for Flotilla, so they came bundled with the Flotilla kits. The red USB cables.
Are these a little bit thicker than the Flotilla ones?
They're the same, I think.
They're the same as the USB cable. The actual Flotilla blue cables are a little bit thinner.
They're quite thin because they don't need to carry anywhere near.
They're the same as the Moat cables as well.
Yeah.
So they come in 4 different lengths: 2 meters, 1 meter, 50 centimeters, and 10 centimeters.
Which is as dinky as they would make them at the factory.
And two different colours, black and red as well. So the black ones go really nicely with the Moat.
And red is
with
great
the
for
Moat driver
visibility.
Yeah.
And the red ones go really nicely with the Flotilla dock.
Yeah.
So,
red things, that's definitely my cable, and not anyone else's.
Yep.
I use red because it's the only one that I can find when I need a micro USB cable. All my other cables are black or white, and the red one is like, ah!
Yeah. Cool. So they'll be up soon. Look for. I think John's going to take them through their paces, and we're going to show you them heating. We're going to show you bad cables heating up under kind of 2.5 amp loads, just to show what the problem is. They'll only heat up by a few degrees, but you'll see the difference.
See if we can completely and totally destroy them.
Cool.
Right, so let's try this demo.
You're eager to get your...
See if it still works. So basically what I've got here is I have a bottle with murky brown liquids, let's call it bilge.
Bilge water, yeah.
Bilge water. I think it's actually coffee.
Oh, I was going to say, guess what it actually is.
It's actually toilet water. No, it's not. And then we've also got a mug here. We have a 12 volt. Let's see if we can get it
hand-eye coordination. Don't put the 12 volt motor in the mug.
Yeah, we've got a 12 volt peristaltic pump. So a peristaltic pump basically has a motor, then it has a little wheel on it, and the cable runs around that wheel, and the wheel's got a little kind of nubbin on it that kind of presses against the tube and pushes the liquid through the tube.
Massages it.
Yeah, very much. It's a bit like just kind of going like that on it.
And it's similar to how a bubble lift works, and then it fires bubbles in and they rise up and pull the liquid.
It's the kind of pump they use in hospitals for drips, so they can very accurately measure the amount of liquids that's being dosed out.
Do you see them in the dialysis machines as well? Kind of big ones?
Yeah.
I guess it's also totally non-invasive to the drip line as well.
Yeah.
Unlike some pumps, like an impeller or something, which is actually submerged in whatever you're drawing through it. This is completely separate. Yeah,
your liquid's never coming out of the tube, basically.
Yeah.
This one, the bit of tubing that runs through through the actual pump part of it, is kind of like fixed in place. The ones that are in hospitals, you can open up the actual pump and then put the tubing in, so you can kind of obviously sterilise the tubing.
It looks like you pull the bottom right off that.
Yeah, I think it does come apart, but it's not.
Let's not do that.
So,
it wants it to actually work.
Yeah.
Has that wire just...
It snapped. This is why you should never strip wires with tin snips. Because I do that and they invariably get weakened.
Use your teeth.
No! My teeth are bad enough as it is.
Man, I could use my teeth.
Here, put this wire in your mouth.
Yeah.
I won't turn it on. I promise.
Yeah.
It's a big clutch.
Oh man, right after Berlin, I'm booked in for my pirate transition therapy. And they're going to pull my teeth out and put like gold ones in.
Gold ones.
Yeah,
right.
It's going to be fun. More news on that later.
That should be a general thing, really. I mean, teeth are just too much work.
Well, we should make it like in the contract of employment on the good ship Pimoroni.
No, I think
you should have at least one gold tooth.
Everyone, once they grow into adulthood and have their full set of adult teeth, should just have them all removed and replaced with like titanium or something. Yeah, something long-lasting, hard-wearing.
Just connected, RFIDs, that kind of thing.
Individual lighting control.
Yeah. If anyone knows anyone who can do RFID teeth, I want to hear from you.
Hold on while I pay.
Dunk. Yeah, I can face desk, head desk to pay for things. Anyway, are we good to go, Sandy?
Yep.
Right. Is the weight on? The scale on?
We'll get to that. I'll just
okay. Right.
Yeah. Right. So what we've got here is we've got a bench power supply that's supplying 12 volts. We've got the load coming out of that supply is running through the normally open side of the relay, and then back out, and then into the positive terminal of the pump. Then it's coming back out from the other terminal of the pump and back into the power supply.
Cool.
So what I'm going to do first is I'm going to put the scales on and then just tear them, and then I'll put the tubing back in.
Oh, nice blue backlight.
It's
so
not.
Glare.
I'm probably going to have to hold my hand.
Somewhere,
let's get that tubing
that works.
Positioned. So the reason it's reading 4.5 is because I've put the tubing in, so obviously it's weighing that. And I've written some code, so I'm going to attempt to dose out 25 mils here. So here we go. So basically I've written a function that, from my calibration I worked out that 1 mil is dosed out every 0.91 seconds. So essentially what I've done is written a function that takes the amount in mils that you want to measure out.
That looks convincingly like 25 mils.
So let's just take that out. Oh, we've got 24.5 mils. That's pretty good.
Pretty
Do you ever have to account for the amount of liquid that might get stuck in the pump, in the hose?
Yeah, I mean there's things like there is going to be some that's stuck in the tubing.
Do you want to try it again? Now we've primed the pump?
Yeah, we'll try it again.
Yeah. So we're expecting this to be, another 25 mil?
Yeah, let's do
so
20. Let's do 20 this time.
Okay.
So I'll just tear the scales again, and then put the tubing back in, and then set it going again. So as I was saying, my function takes the amount in mils multiplies that by 0.91 seconds, and then switches the relay on, and then sleeps for that mil amount times 0.91 seconds, and then switches the relay off again. Oh, so we've got 19.8 that time. So we're getting closer. There's always going to be a margin of error in these things.
Especially when you're using a pi in Python to control the pump.
Because obviously when you lift the tubing out, there might be a little drip in the end of the tubing that falls out.
There are many factors at play.
That's pretty close.
So that's the kind of thing that you can do with Automation Hat. Phil has also connected up the terminals of the motor to the ADC. So we should be able to, if I open up a new tab,
I think two instances of the library will probably crash and burn in a horrible fashion. So you might need to replace the sleep.
I'll let you do that,
with some sort of ADC read.
So which calls are you using here in Python? It's the normal Pimoroni way, right? Import automation.
Yeah, so I mean I'll write a tutorial up on this, and I'll put the code up. But I mean it's essentially about 10 lines of code to do all of this. So it's import the Automation Hat library. So that's just import Automation Hat. Then, like I said, there's a function that I've called doze, and that doze function takes the amount in mils. Then it multiplies it by 0.91 to get the delay time. We've also imported the time library, the Python time library. That allows you to wait for a certain number of seconds. And based on my calibrations, I worked out that there was one mil every 0.91 seconds.
Can we get closer to your circuitry there as well, just to see how you've got that set up?
Yeah, let's have a look at that.
Just for people who are kind of wondering, relays, aren't they a bit scary?
How am I going to do this?
So you can see there the things coming in from...
So I'll just move this. Oh. So you may be able to see, if I get the pointing device, that each relay has a normally open side. That's the one labelled NO. They've got the common in the middle, and then they've got the normally closed. So basically the relays are just like switches. The normally open side is exactly what it says. If the relay is not switched on the normally open side, then it's open, so it's disconnected. When you toggle it on, then it's going to make that connection and switch it on. The normally closed side is the opposite, normally closed, and then when you toggle it on, it opens and breaks that connection.
Cool.
So essentially, if you want to switch something off, then it's better to, if your default behaviour is to switch something off, then you want it connected on the normally closed side, and vice versa for the normally open.
You've got some readings there?
I've got some readings. No, I just need to modify the original function for dosing.
Richard is asking how much the pumps cost. This one is from Adafruit, and I think it cost about $30.
Yeah. But eBay, eBay.
Yeah, you can pick them up on eBay.
We'll have a look around for them, because now we've got the relays and the automation out, we need to start stocking more stuff, including restocking our nice 12-volt power bricks that we used to have for the 12-inch screen for the Bikeade before they disappeared forever from history. Let's see if we can watch Phil doing this.
Let's see if I can monkey patch time.sleep with my new delay.
Sure. Oh, we mustn't forget to cut the power on this and see what happens. So that'll be...
what is going on with this pie?
The touchpad, isn't it?
What? Oh, it's the touchpad on the right of the keyboard.
What's happened to the close-up cam?
No, it's really, really close, I think. Really zoomed in.
I've broken it.
There we go.
Yeah. So hopefully when Phil finishes this, we'll be able to look at the screen and see what's going on.
No, I've made a horrible mess of it now.
Yeah.
Man, live coding, not even once.
So the other kind of uses that we've thought of for Automation Hat are things like if you wanted to, on your espresso machine, monitor every time that it was used, then you could hook up the inputs on Automation Hat to the switch on the espresso machine, and then monitor every time that it was used. Or you could use the relays or the outputs to actually toggle the coffee machine on and off.
Yeah.
And then you've got
We had a brief look at that yesterday.
you've got remote control.
You wrestled with an espresso machine yesterday.
Those
things are well made.
Yeah, I spent about an hour trying to get into an espresso machine. Oh, and it was for some reason they've used clips to hold everything together. So the outer panels are all clipped in. So you've got to like pry open about 8 or 10 clips to get the outer panels off. Once you get them off, there's another 2 panels on either side that are all clipped in as well. Absolutely no screws in sight.
Yep.
So you then have to like pry those bits open. That's round about the point where I gave up because I wanted the coffee machine still to be functional. So
next time, it's a backup. We'll tear it apart properly. Somebody was asking you about connecting the moat to a Pi Zero with a micro USB to micro USB. You're in luck. If you look at the moat page on Pimoroni, those cables are micro USB to micro USB, and they're electrically compatible, and they are heavy gauge. They are 22 org. So let me just bring this up on the screens. So there you go. If you look, we've got moat modules and cables. If you click view more details, we've got a full range of the moat cables, which are micro USB to micro USB connectors, out of spec completely for USB, but really useful if you want to connect a moat controller to a Pi Zero. So yeah, whoever was asking that, that's how you do it. Yeah.
I didn't even port time.
They are kind of on the go-esque.
Before I was being so clever.
I think we actually demoed that, didn't we, on the cable special?
Yeah.
At the very end of that episode, Phil made some kind of horrendous Medusa-like concoction of cables. One of which I think was one of the motor flotilla cables.
To the close-up.
Here we go. Let's get that.
Wow.
So there we go. So it's reading 11.99
to a ridiculous number of significant digits there.
So that's nigh on 12 volts.
How many mils did that dose out? We'll never know.
Let's just get this. The bench power supply is reading 12.04 volts.
So very minor bit of drop through the cables.
So there's a tiny bit of drop through the cables.
These aren't exactly
Which
the
makes sense.
best of cable setup. There's a few joints and connections that will certainly cause a voltage drop.
Yes.
It could be a
0.1
short
volts.
length of NAF jumper wire, but yeah.
0.1 volt drop seems fair to me, assuming it's totally accurate. Cool. And the other thing, can we turn it on and unplug the Pi?
Oh yes.
I guess now we've got the script, we can turn it on.
Yeah. Final test. What happens with the latching?
I can't turn it on. Why does this never work for me? I keep clicking out of the thing.
So Chris, if you're having problems with the moat and the Pi Zero, drop us a support email again, poke us on Twitter, and we'll see if we can work out what's going wrong with your setup.
No, it definitely turned off.
Yeah.
There you go. So non-latching.
We didn't need to do
this. I mean, that's a good feature to have, because obviously if you're automating something and you have it switched on, and then you've got it set to a precise schedule, and the power gets cut to the Pi somehow, then you probably do want to switch it off.
That's how it fails safe.
Not have it left on and flood your kitchen or.
Yeah, that would be one of those instances where you'd use the normally open side of the relay. If you wanted it to fail on, for some reason, you might want it to fail on, you never know, then you'd use it normally closed, so when your Pi loses power, it would turn on.
Yeah. Somebody's mentioned tungsten for teeth. As far as I know, tungsten, very dense, very heavy, which would be kind of cool. But titanium should also be pretty biocompatible.
Tungsten teeth also has an alliterative quality to it that I quite like.
I'm not sure what the conduction is like though, because one of the things with gold is it conducts very well, so you really feel it when things are hot in your mouth or cold.
Yeah, I'm getting that with my metallic filling. It's like
Whereas titanium just doesn't do that very much.
I think it's a very good conductor, tungsten.
Right. Yeah. So titanium's still looking like the winner, but we'll see what happens in the process.
Yeah. Maybe Teflon.
Teflon
teeth
coating. I'm not sure.
Isn't Teflon supposed to be toxic?
Yeah. This is why they
Allegedly.
recommend, like, if your plan's like peeling its Teflon coating, maybe stop using it.
Which they are all the time.
I mean, probably in California, everything's carcinogenic in California, even buildings.
And the Daily Mail.
Yeah. Don't use it to wipe your bum.
There's a brilliant website of things that the Daily Mail have said cause cancer and things that cure cancer. And if you draw a Venn diagram of all of the things that the Daily Mail says cause and cure cancer, then the overlap is
more significant than it really should be.
Pretty big.
Well, this is just the
those things, they'll balance out.
Yeah, scientific reporting in tabloids is generally quite poor compared with the actual study that underlies them. But we know that. Yep. You know that better than most.
We have an actual scientist in our midst.
So you were telling me you were part of the research, or you did the research into sequencing fruit fly genomes?
Not the tsetse fly.
Tsetse fly.
Yeah, so in my previous life I worked at the University of York.
Yeah.
And I was a data analyst analysing biological data. And one of the main things that I did was sequencing and annotating genomes, especially insect genomes. So I worked on the aphid genome sequence, also the tsetse fly genome sequence.
Cool.
And then various bacterial species that are probably not as interesting.
Yeah. So if anyone wants to pop quiz Sandy about a particular part of the tsetse fly genome, I'm sure he can just parrot off parts of it. It's not that long, really, is it?
Yep.
Compared to human DNA.
Yeah, it's only
What was it? A couple of megabytes at best. How
It's
long's the human one in kind of plain text as such? It's like 20 meg, isn't it? 40 meg?
Is it
Gig?
that big? No, surely not.
I'm sure it wasn't that large.
Not anywhere near that.
Yeah,
It's a year since I downloaded
Shockingly
it
small.
for reasons.
I can't remember offhand, to be honest, the lengths of the ones that I sequenced, because the weird thing about more advanced species is that the size of genome can vary massively between different species and not in any kind of regular way. So something that can happen is it's quite interesting. The whole genome of an organism can duplicate. So some organisms actually have multiple copies of their genome, and obviously every time that happens, then the size of the genome is going to double or quadruple or whatever.
Yeah.
Good redundancy though.
Yeah.
Well, they're going to do proper backups, I assume. So there could be mismatches in there.
Keep over the air backups of my genome.
We should do a special spin out like Sandy's biology lessons or something like that.
Yeah. Absolutely, man.
Somebody takes issue with you saying bacteria aren't as interesting.
Oh yeah, no, I mean, yeah, I'm a bacteriologist actually. That's what I started out as. My first degree was in microbiology, so yeah, absolutely, bacteria are, dare I say it, more interesting than more advanced life forms. But yeah,
you can do more with them, you know.
Yeah.
Whereas humans, they're always going to end up being basically human-shaped, aren't they?
Yeah.
Whereas bacteria can do all kinds of interesting things.
That's where
Freaking retroviruses.
That's where we all came from.
Are they like retro games?
Not quite, no. It's just they start with RNA and then kind of make the DNA backwards. It's like their natural format is RNA, which is like not the way it's supposed to be.
Yeah.
Anyway,
Science stuff.
Thanks for watching us pump some bilge water very
Yep.
gently
Nice.
and with some accuracy.
And we'll try to do some more scientific bilge tank episodes in the future.
Science!
Yep.
Right. In the meantime, don't forget to like,
Comment.
And subscribe.
unless you're going to be a dick in the chat. And
I don't understand why people do that. So.
attention. That's why we're here.
Level of offence taken, none.
Right.
Consummate professionals, don't you know?
We'll probably update you from Berlin, but it'll probably be re-recorded as the Wi-Fi at Make Fairs is normally a little bit patchy.
Yeah, this is going to be an interesting one, isn't it? How are we going to try and live stream?
Not live stream, I don't think.
We could
Because
try
none
and
of us can do
Periscope,
the.
maybe.
Yeah, we could do a few periscopes. That'd be quite
I
good.
don't know what my broadband allowance will be, but my phone will work abroad this time.
Yeah, I've got 3, so they now roam in Germany.
Me too.
Thank you, Free!
All 3 of us have got 3.
Yeah,
3 of
Three
3.
threes.
three
So
threes.
between us, we
All
might be
threes
able to
again.
get 1 live stream out of the broadband allowance.
Yeah, we'll see.
Just
I've
round robin it.
got the Osmo camera as well, so I'm going to be running around doing that
so cool.
gimbal. And now I've got the stick for it, so I can do like flying gimbal shit. Stuff. Sorry, it's quite school hours. Right, anyway, look forward to that. We'll be being kind of lol pirates in Berlin. It's going to be a lot of fun.
If you're there, see you there. Bye-bye.